All right, guys, today's goal, the learner will be able to use inverse functions. Recall that you learned that a relation is a pairing of input values with output values. An inverse relation interchanges the input and output values of the original relation. This means that the domain and range are also interchanged. So here's the original, here's the inverse. See what they did? They flipped the x and the y. It reflects it over, okay? Reflects it over the line y equals x. So how do you find an inverse? Flip the x and the y. So it says inverse functions. Functions f and g are inverses of each other provided that f of g of x equals x and g of f of x equals x. The function g is denoted by f to the negative 1, which reads as f inverse. Okay? So what did we say with that table? Switch the x and the y. So watch. X equals y plus 4. Now solve for y. So subtract the 4. X minus 4 equals y. So now we have to test it. So we are saying g of x equals x minus 4. So f of g of x would be x minus 4 plus 4. That equals x. That's what we wanted, so there's check 1. Now, g of f of x equals x plus 4 minus 4. That equals x. So, check. So, yes, this is the inverse. Okay? So, let's do it here. Switch the x and the y. X equals 2y minus 1. Add the 1. Divide by 2. So there's your inverse. So now let's see. So instead of y, we can say that is g of x. So let's find f of g of x. So I'm plugging g of x into f of x. So I get 2 well, that equals x plus 1 minus 1. That equals x. Now we need to do g of f of x equals, well, we get 1/2 times 2x minus 1 plus 1/2. That equals x minus 1/2 plus 1/2. So that equals x. So did they both equal x? Yes. So there's my inverse. Okay? So number 3, you guys please do on the board or on your own. Bring it in completed tomorrow. Finish that up. Find the inverse, verify. So, inverse of nonlinear functions. The graphs of the power of functions f of x equals x squared and g of x equals x to the third are shown below, along with the reflections of the line y equals x. Notice that the inverse of g of x equals x to the third is a function, but that the inverse of f of x equals x squared is not a function. Okay, so this is a function. This is not a function. Now remember, we learned how to do the vertical line test to test to see if something. To see if its inverse is a function, you do the horizontal line test. Now watch. See how here that horizontal line hit 2 points on the original? That means it is not an inverse. Now if I go through this, or its inverse is not a function. See how here, everywhere I go, I only hit one line, one spot? That means its inverse is a function. That's what this is saying. Okay? So find the inverse of the function, then graph the function and its inverse. Okay? So switch the x and the y. So you get x equals y to the sixth. How do we solve that? Sixth root. Now why am I not doing plus or minus the sixth root of x? Because right here, do you see how this is saying x is greater than or equal to 0? That means only when it's greater than or equal to 0. Okay? So I don't need the negative roots because that's not greater than or equal to 0. So I'm going to set up two tables. Here's f of x. G of x. Okay? Now watch. I'm going to use 0, 1, and 2. If you plug that into f of x, 0 to the 6th power is 0. 1 to the 6th power is 1. 2 to the 6th power, 64. How can I get these? Well, just flip them. So you go 0, 0, 1, 1, 64, 2. So let's graph these. Here's the, so that's going to be too close. I need to get 8 lines in here. So 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to say this is 8 and this is 8. So that lets me know the scale. So I'm going to graph the first one. There's 0, 0, 1, oh. 1, 1 is going to be like right there, and then 264 is going to be way up here. So this is going to be real quick. And it's probably going to be closer. It's just really hard to do. And then flip this. So you go 0, 0, you go the 1, 1, and then you go the 2, or the 64, 2. See how both of those are functions? Okay, so let's try another one. This says f of x equals 2x to the 5th plus 3. It doesn't say anything about domain values. So just switch the x and the y. Subtract the 3. Divide by the 2. So you get y to the 5th equals x minus 3 over 2. Take the 5th root. See, it doesn't say anything because you don't need to worry about positive or negative values in order to be a function for odd roots, for odd exponents. So you have y equals 5th root x minus 3 over 2. So let's make our tables. I'm going to do negative 1, 0, and 1. Here's f of x, g of x. If I plug in negative 1, I get negative 2 plus 3, positive 1. If I plug in 0, I get 3. If I plug in 1, I get 5. Well, switch it. So you go 1, 3, 5, negative 1, 0, 1. So this one, we can just mark some lines. We don't have to make a scale because it's just going to be 1. So negative 1, 1, 0, 3, 1, 5. So this starts going like this. And then switch them. So 1, negative 1, 3, 0, 5, 1. So this is going to go like this. Okay? So there we go. So word problems. The body surface area in square meters of a person with a mass of 60 kilograms can be approximated by the model. A equals 0.2195 h to the 0.3964. Where h is the person's height in centimeters, find the inverse of the model. Then estimate the height of a 60 kilogram person. Okay? Who has a body surface area of 1.6 square meters. Okay? So, what I need you to do is find the inverse, and then this piece right here is going to be the bell work. So just try to find the inverse of this equation, please. See you guys tomorrow.